Hello, Math 101 students. Can you hear me? Okay, good, good. Okay, welcome to week number 2, and I hope you had a good weekend. Um, Today, everyone, we're going to do the following. Here's the plan for today. Uh, the plan for today is, okay, announcement. Okay, little announcement about the location. Many of you probably know that we use the live class materials module to find out the live class, in-class exercises, and so on. So for today, we're gonna do trig differentiations and module 2-1 in-class exercises. And you can go to Canvas if you want and click the slides, and maybe you don't have time for print, but then if you have a tablet or something, you can annotate on the slides. And these are not for marks, so if you want to write it at the later time, please do so. Okay, here's the quick announcement. And so, as many of you know, uh, quite a few people taking Math 101 this term are from Math 116. So I think it's a good idea to go over some of the derivatives of trigonometric functions, and maybe possibly review some of the product and quotient and chain rules. We're not going to spend too much time, but 1 hour is enough, I think. So from 2:30 to 3:30, we're going to do that from Math 100 or 116. And once it's done, everyone, you can go ahead and do the self-study, have the self-study period from 3:30 to 4:10, and you can choose to do one of the following. Lecture videos. You can study lecture videos, or you can study in-class exercises for module 2-1, or ask questions if you have any. For example, any questions, like not just the module 2-1, but it could be from week 1 as well. At 4:10, we're gonna go over solutions to the in-class exercises. Okay, so that's our plan. Are you guys ready? We're going to start doing some calculus 1 stuff, derivatives of trigonometric functions. Not so much, but just enough for integral course. Here you go. As many of you know by now, even if you took Math 116 before, we know that the derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of tangent is secant square. The derivative of cosecant is negative cosecant x cotangent. It looks ugly, isn't it? Derivative of secant x is secant x tangent x. Derivative of cotangent is negative cosecant square. So everyone, whenever I say, what is the integral of cosine x? Whenever we say integral, you go back. It's sine x plus c. Whenever we say integral of secant square, you go back and it's tangent x plus c, and so on. So these are the primary 6 derivatives of trigonometric functions. We're going to do more harder ones in week 2-3. But harder ones, for example, like this, sine, what is integral of sine of 2x kind of thing. This one requires kind of chain rule for integral, right? So we're going to learn that in module 2-3. It's called the substitution rule. By the way, for those of you who took Math 100 and 116, either with me or someone else, what kind of rule should I use to differentiate x squared multiplied by sine x from calculus 1? Okay, chain rule. Okay, Ishika chain rule. Davis product. Anyone thinks otherwise or same implicit? Okay. Okay. Surprisingly, everyone, all of the answers are correct, but if I have to choose the most correct answer, it's Davis's answer about product. Did you guys just hear what I said? X squared multiplied by sine x. Do you know, whenever we say multiply, the word product comes into our mind, right? Product of two functions. So for example, x squared multiplied by, what is that? Sine x. Do you know why I said, Maya's, Ishika's answers are also correct? It's because in a way, we are using the chain rule, everyone. Even if you have a very simple function like this, y equals x, what is the derivative of x? Well, we all know that derivative of x is 1, but if you really want to use chain rule, it's actually dx by dx, the derivative of the inside. But dx over dx is just 1. That's why we actually kind of ignored the chain rule for this kind of simple function. So that's why Ishika's, Maya's answers are also correct. But anyways, to choose the most appropriate answer in this setting, we have to use a product rule, x squared times by sine x. In case you forget about the product rule or quotient rule, I'm gonna write down the formulas for you. It's this. Product rule looks like this. If two functions, let's say we have some blue function f, green function g, are multiplied together, okay? If they are multiplied together, and then you want to find out the derivative, it becomes what? The derivative of the first guy, which means f prime, f prime times by the original second g plus original first guy f times by the derivative of the second guy g prime. So that's the rule, okay? Whenever we have a product of two functions, this is a product rule. And the quotient rule is, it's kind of opposite of the multiplication. The opposite of the multiplication is division. Division means, say I have a top function f, say I have the bottom function g, then the quotient rule says the derivative of the first guy, same as before. Everyone, how about let me make your life easier by just copy and paste the original product rule, except the plus sign becomes what? Plus sign becomes, if anyone remembers quotient rule, the top of the quotient rule becomes exactly same as product rule, except plus sign becomes the minus sign. So like this, f prime g, instead of plus, you have to change to minus, and then f g prime, okay? And then all over the bottom square, which means g, the original g square, like this. Okay, I am assuming many of you know already the product and quotient rule. And the reason why I'm teaching you this is because I want to solve this problem for you. What is the derivative of the following function? Y equals x squared times by sine x. Take a look. Our first function is x squared multiplied by the second function, which is sine x. Sine x. Did you guys notice that we have first and second, then the blue prime times by the original green plus the original blue times by the derivative of the green. So the answer becomes y prime equals, everyone, the derivative of the first guy, which means 2x, times by original second guy, which means green, sine x. Okay, like so, everyone. And then plus original first guy, which means blue original, x squared. And then the green derivative of sine x is, everyone? The derivative of the sine x is cosine x. Thank you. So that's all, actually. If you knew the product rule from Math 116 or 100, you just have to know the derivative of sine x is cosine x. That's the whole point of today's lesson. Just become familiar with the trigonometric functions. Okay. All right, everyone. Suppose I want to find out the integral of sine x, not the negative sine x. So suppose I'm going to integral now. Integral of sine x. According to our setup here, can anyone tell me the answer for this? Integral of sine x dx is equal to, I'm talking about the integral, not the derivative. Okay. Please, Davis's answer is correct. Please do not forget about the negative, okay? Because if you move the negative to the other side, the derivative of negative cosine is positive sine x. So integral of sine x dx is actually negative cosine x. Oh, oops, sorry. It's plus c. So I hope you don't forget that, okay? That's important, negative sign. Okay, let's keep talking about the derivatives instead of integrals. Okay, move on to the next slide. And I'm not going to do the part A because it's exactly the same as what I just did. Instead, here's the question. Differentiate y equals secant theta times by tangent theta. Let's see if anyone has a very good memory. What's the derivative of secant x and tangent? Oh, this is not easy. Okay. I was thinking about the integrals, but we're talking about the derivatives, right? Derivatives. So what kind of rule would you like to use? I'll give you 3 choices or 4 choices. Product, quotient, chain, implicit. In order to solve for B, yes, we have to use the product rule. Okay? Okay, so I'm going to make the blue color for the first function, and I'm gonna make the green color for the second function. So just feel free to use the product rule. This becomes y prime is equal to the derivative of the first guy. Ooh, okay. Now it's time to test our memory. Derivative of secant theta is? It's long. Oh, thank you, Davis. Secant x times by tangent x. Yes. Secant theta times by tangent theta. That's our first derivative, f prime. Okay, I think it's correct. Derivative of secant is secant x tangent x. Good job. And then now, the original second is just copy and paste the tangent. Just copy and paste the tangent. And then plus, now copy and paste the original blue, secant theta, times by the derivative of the green. Who has a good memory? Derivative of the tangent. Okay, Ishika gave us the full solutions, which is correct. And Local and Henry, good job. Derivative of the tangent is secant square. So in green, I'm gonna make it as a secant square theta like this. And therefore y prime is equal to, just like the Ishika mentioned, secant theta times by tangent square, because we have a tangent times by tangent. So I'm gonna put it in red color, everything. Secant theta times by tangent square theta, like this, plus, everyone, secant theta times secant square becomes secant to the power of 3 theta. And there you go. This is your derivative using the product rule, okay? Yes, everyone, one of the exciting moment in week 4, or week 3 or week 4, we're going to learn how to do integral. Actually, it's week 4, I remember. Integral of secant theta, tangent square theta d theta. And then we're gonna find integral secant cube theta d theta. Everyone, this is what we're going to do in the future. And to tell you the future, if I tell you the future in advance, secant cube theta d theta, it looks easy, but it's not. I'm gonna teach you once in this term, but it's gonna be very long work, a long process to get the answer. This one is not so bad. Okay, but you guys really have to know module 2-3. There's a small typo. There's a small typo in module 2-3 video. At 35 minutes mark, but I'm going to give you guys a global announcement about this small mistake. It's just I forgot to do the feed chicken. So okay. All right. So that's about it, everyone. And then here's our future. We're gonna find the integral of this, integral of that. Okay, that's in week 4. Okay. What kind of, look at part C, everyone. What kind of rule would you like to use? We have 4 choices as usual: product, quotient, chain, and implicit. Like Benjamin mentioned, quotient is the right one. So quotient rule, let me show you one more time. And Haley, I'm gonna answer your question soon, okay? Um, oh, okay. Haley, it's 35 minutes. 30, okay. 35 minutes. 35 minutes mark. And about 40, 40 seconds. Okay, I think. 35 minutes and 40 seconds. Yeah. But I'm gonna give you guys the screenshot of the problem and then attach that into your email. So I'll send it to you today. Okay, someone already has the answer. I was gonna show you the formula for the quotient rule. If you have a top function divided by the bottom function, it's same as f prime g minus f g prime divided by the original bottom square. Okay, so let it begin. We have a top function at the top. That's obvious. Bottom function at the bottom. So the derivative of the top is 8. So here's y prime. Y prime is equal to, the derivative of the top is 8. And then the bottom, oops, sorry. And then the original bottom is 1 minus tangent x. And then subtracted by original first guy, which means 8x, times by the derivative of the second guy, which is negative. Please don't forget the negative sign. Negative secant square. Negative secant square. Okay, like this. And everything divided by the bottom square, which means 1 minus tangent x. So 1 minus tangent x square. Just quick yes or no. Are you guys following me okay with the quotient rule? Good. Good. When I was teaching Math 100 or 116, I did not ask students to simplify. And I don't want to do that, wasting time simplifying things at the moment. So because my main purpose for teaching this is to do integrals with a trig in pretty soon. So okay, but if you simplify negative, this becomes what? It becomes positive. That's something that we can do. That's easy. Okay, so congratulations. We've successfully finished the basic differentiation of trigonometric functions. How about something that we didn't do today? Something that we didn't do is the chain rule. I don't know how many people took the calculus 1 with me, or at the UBCO. How I usually teach chain rule is that students need to know what is the outside, what is the inside. Let's see, even if you didn't take a course with me, let me ask this question. Which one is the outside? Which one is the inside for this function, everyone? Okay. Filson, good job. And then Tanya, good job. Inside is sine. So Davis summarized everything. Outside is sine. Inside is also sine in this case. But if you want more interesting problem, okay, let's see if you remember from Math 100. This is a tricky one, okay? How about this? E to the power of uh, sine x. If I give you this kind of function, everyone, what is the outside? What is the inside for this one? Okay, okay. Filson, and okay, good job. Okay, take a look. Ishika, look, Ishika has the most appropriate answer. And Filson, I think, is meaning the same thing. This time, Davis, okay. Inside is sine x, actually, okay, not outside, okay. In this case, everyone, the outside is actually e to the power of, can I put a huge, huge space over here? This is the outside. This is the outside. And then inside is in green. Take a look at my green. Sine x. Sine x is the inside. Okay. So hopefully you know that as well. Okay. Now, if I rewrite our original function here, y equals outside in red color, sine of this, and then the inside in green color, sine x. Now you clearly see which one is the outside and which one is the inside, everyone. Once you figure that out, let's go ahead and find out the derivative of the outside, because the chain rule is, everyone, the chain rule. There are a couple ways to write the chain rule, probably two ways, but here's the informal way. The chain rule is outside prime times by uh, inside prime. But when you're doing outside prime, you have to be a little bit careful. When you're taking the derivative of the outside, please do not change the inside. For example, take a look. Y prime is equal to the derivative of sine is cosine, right? So you change the outside function like this. If you heard what I just said, what happens to the inside when you're doing the derivative of the outside? Do you change the inside? Yes or no? Okay, good job. So you always have to copy and paste the original inside. Multiply that by the derivative of the inside. The derivative of the inside is cosine x. And congratulations, everyone. This is the full solution to the, well, not the solution, but the derivative of the original function. Sine of sine x, each derivative becomes cosine of sine x times by cosine x. This is your derivative. What's another name for derivative for grade 10 students, grade 10 mathematics students, high school students? Starts with S. Another name for derivatives starts with S. Okay, good. That's called a slope. So this is actually, more precisely speaking, y prime is called instantaneous slope. But just for simplicity, let's just call it, with my fancy color, y prime, just call it slope. But hang on, everyone. Whenever we talk about the slope and a line, tangent line, slope is just a part of the tangent line, but so that means y prime is not the full answer to the question. So if you want to find out an equation of the tangent line, equation of the tangent line looks like this. Y minus y naught, it's just my personal preference. point slope form, y minus y naught equals the slope m times x minus x naught. Okay. In this case, we know the derivative, y prime, right? Y prime. This m is called the slope at x naught, which means slope at 4 pi. So if I rewrite this, it's f prime of 4 pi times by x minus x naught and then y minus y naught. Let me tell you something. X naught is 4 pi, right? So let's put 4 pi here. But you got to tell me this. What is the answer for the y naught in this case? Looking at the question. Looking at the information here. Good. The y naught is given to be 0. So when x naught is 4 pi, y naught is 0. Like this. So technically, everyone, you are almost done with the problem. You just have to find out f prime of 4 pi. How do we find out f prime of 4 pi? You just have to plug 4 pi into the x here. You just have to plug 4 pi into the x here. So f prime of 4 pi is equal to cosine of sine of 4 pi, cosine of sine of 4 pi times by cosine of 4 pi. Okay, now this is something, okay, from now on, you don't need calculus 1. You have to know some sort of calculus, pre-calculus actually, pre-calculus. Does anyone remember what is sine of multiple of pi? Sine of multiple of pi in yellow highlighted here portion. Okay. Just 1 pi is, 1 pi is 180 degrees, but I'm not talking about the degrees actually. I'm talking about what is the y value when you put the 4 pi. 4 pi is like 720 degrees, right? Sine of 720 degrees is, just like people mentioned, Maya, Jenna, and Sam. Correct. For those of you who are a little bit confused with this one, could you please remember, sine of a multiple of pi is always 0. It's always 0. It's always 0. And to explain why, okay, let me quickly show you the graph of sine x. Does anyone remember the shape of the sine x graph? It looks like this: up and down and come back. Do you understand? So that's the normal sine x graph, right? And sine x is 0 whenever you have multiple of pi, like 0 here, pi here, 2 pi, 3 pi, 4 pi, and so on. Do you understand, everyone? So that's why whenever you have a multiple of pi, your y value becomes 0. That's why sine of 4 pi is also 0. Does that make sense? Henry and James. Okay, good. Thank you, James. 180 degrees is just pi, so 360 degrees is 2 pi. Yes, that's correct. So now that you guys know sine of 4 pi is 0, what is, everyone, what is cosine? Cosine of 0. Okay, good. Sam, Jenna, good job. Cosine of 0 is just 1, because if you remember graph of cosine, unlike the sine graph, cosine graph starts at the top and come back, and it looks like a kind of a bell curve shape upside down. Now, did you guys notice that when cosine is 0, the y value is actually 1? 1. This is the reason why cosine of 0 is just 1. And then cosine of 2 pi everyone, when cosine is 2 pi, you come back to 1 as well. So here's my question. If cosine of 2 pi is 1, okay, if cosine of 2 pi is 1, what is cosine of 4 pi? Anyone? Okay, good job. Good job. If cosine of 2 pi is 1, cosine of 4 pi is also 1. So it's like kindergarten. Well, maybe not kindergarten. It's like a grade 1 problem. 1 times by 1 is 1. Therefore, our slope of the tangent line was just 1. So this becomes y is equal to 1 times by x minus 4 pi. Or you can just ignore the 1 and just write down y equals x minus 4 pi, just like the y equals mx plus b form. Okay, there you go, everyone. This is the answer for the slope of the tangent line of this curve at the given point, 4 pi comma 0. Okay, hopefully this is a good review for many of you. Okay, and module 2-3, once again, we're learning the chain rule for integrals. The name for the chain rule for integrals is called the substitution rule. Substitution rule. Okay. Okay, I think that's the end of this example. Besides calculus problems, I chose some pre-calculus problems that might be helpful for the future. Oh, sorry, still calculus. Okay. Yeah, sorry, I totally forgot about the derivatives of inverse trig functions. It's also very important. When we say inverse trig functions, it looks like this: sine inverse of x, cosine inverse of x, tangent inverse of x, kind of thing, eh? There's another way to write down inverse functions, inverse trig functions. Instead of writing -1, some people write down arc sine. Some people write arc cosine, and so on. Okay, so if you didn't know the difference, they have no difference. They just mean the same thing. You can write sine inverse or arc sine. It's up to you. If you want to write cosine inverse this way, please do so. Otherwise, you can write arc cosine. Same thing. And the whole point of this slide is to find the derivative of these such functions. Okay, here you go. Here's a summary of derivatives of such functions. Derivative of sine inverse is 1 over root 1 minus x squared. So for the future, if you ever encounter a problem, integral of 1 over root 1 minus x squared dx kind of thing, whenever you see this kind of problem, please don't be afraid. It's basically sine inverse x plus c. Sine inverse x plus c. Does that make sense, everyone? And whenever you encounter a problem, integral of negative of the same thing, if it's negative, then the sine inverse becomes cosine. Cosine inverse, like this. Okay, and it's my favorite one. My favorite one is this guy. The derivative of tangent inverse is 1 over 1 plus x squared. In other words, integral of 1 over 1 plus x squared dx, it's equal to inverse tangent x plus c. Inverse tangent x plus c. Okay. Because it's my favorite one, it's the chance of you see this on the exam is very high. Put a star. Of course, it doesn't mean you just have to memorize this only. I want you to memorize these two at least, this guy and this guy. But for the other ones, the other three, you do not need to memorize. Do not need to memorize. Because I rarely give questions like, involving this. But if I do, then you'll be given some announcement in advance. Okay, but memorize these things. It's quite popular, and it comes to the exam quite often. Okay, so shall we go ahead and then try some finding the derivatives of such functions? Right here. Here's the first question regarding derivative of inverse trig functions. Find the derivative of y equals something, okay, bracket, inverse tangent x bracket square. Whenever you see this, out of four traces, product, quotient, chain, implicit, what kind of differentiation rule would you like to use? Okay, James, good job. It's many people quite often forget about the outside, but actually there is outside. For example, here's something to the power of 2. In red, this is the outside. And then the inside function is inverse tangent x. So inside function is inverse tangent, like so, everyone. So now you see we have outside and inside. So let's try the chain rule. Y prime is equal to, okay, just correct me, take a look at my work and let me know if I'm doing it correctly or wrong, okay? So derivative of the outside, you bring the power 2 down, and it becomes 1. And then the derivative of the inside, according to the formula, it's my favorite one, 1 over 1 plus x squared. So 1 over 1 plus x squared. Yeah, am I correct or wrong so far? I brought the power downstairs, and then I found out the derivative of the inside. So I did the outside derivative first, and then the next I found out the derivative of the inside. Yeah, am I correct or wrong? Anyone thought it looks like it's correct? Okay, by the way, Odessa and Jenna, good job. It's wrong, by the way. My work is wrong, and I made a mistake on with the purpose, because I do not want you to forget about the chain rule. Whenever you're doing the outside, please don't forget to copy and paste the inside without changing the inside. However, you multiply the derivative of the inside. The derivative of the inside becomes 1 over 1 plus x squared. There you go. You don't have to simplify. That's the answer. Okay. So hopefully you don't forget the blurred inside. Okay. Let's try one more time. This time we're gonna use sine inverse. What is the derivative of y equals sine inverse of 2x plus 1? It's actually chain, product, quotient, chain, implicit. Once again, we have to use the chain rule, everyone. The chain, because our inside is 2x plus 1, that's our inside. And our outside is sine inverse. This is our outside function. So once again, we have to use the chain rule, but look at the outside, sine inverse. For the sine inverse function, the derivative is 1 over root 1 minus x squared. So let me write it one more time for you. Derivative of sine inverse of x is 1 over root 1 minus x squared. Okay, everyone? Next, suppose I don't have x. Suppose I have something uh like love. I'm just making up, okay? Suppose you have sine inverse of love. What happens to the x underneath the fraction? Yes, change x to the hurt as well. So here's my question. Suppose you treat the inside 2x plus 1 as the love or hurt symbol, then it looks like what, everyone? It looks like y prime is equal to 1 over root 1 minus what goes inside the bracket, everyone? Good. Good job, James. The inside, which is 2x plus 1. So the inside, which is the hurt. So 2x plus 1, like this, everyone. And then please don't forget that you have to multiply that by the derivative of the inside. The derivative of the inside is just 2. Okay, there you go. And here's the this is the full solution to the derivative of the inverse trig functions. For our future contents in integral calculus, I want you to remember something. Y equals inverse tangent x graph looks like everyone, inverse tangent x graph has two asymptotes. Does anyone remember where the asymptotes happen? The horizontal asymptotes happen for inverse tangent x. There are two asymptotes. Okay. Okay. Tong, can you try one more time? It looks like 1 and -1, but it's totally unexpected number. My hint is, what is the vertical asymptotes? Vertical asymptotes for tangent x graph. When does the vertical asymptotes occur for the tangent x functions? Okay, good job, Tom. The tangent x curve has asymptotes at pi over 2 and negative pi over 2, like so. So inverse means you switch x and y. Switch x and y means if you had the vertical asymptotes before, you should have horizontal asymptotes for the inverse. So instead of having vertical asymptotes before, we're gonna now have horizontal asymptote happening at pi over 2 and happening at negative pi over 2. Does that make sense? So these are the two horizontal asymptotes for inverse tangent, and the graph looks like this. Instead of going, opening opposite direction up and down, it's like opening right, left. So this is called inverse tangent x graph. And why am I teaching this, everyone? It's because later on, you might have to answer this. Limit as x approaches infinity, inverse tangent x. Limit as x approaches infinity, inverse tangent x. The y values become close to pi over 2. Pi over 2. So the whole point of teaching this is that if you know the graph, then you should be able to answer this kind of limit in a long run, week 4 or so. Okay. I think that's the end of the calculus. And I still want to teach you some pre-calculus that is very helpful, like evaluating sine of some angle, cosine of some angle, and so on. Um, do you guys remember? Do you guys remember special triangle? Like type 1 special triangle looks like this. Uh, like one hypotenuse is 2, and then square root of 3. Good, you guys remember, eh? Special triangle. That's a angle here is 30 degrees, angle here is 60 degrees, and so on. But in calculus or above, we always use radian instead of degrees. So the angle opposite to the 1 is pi over 6 radian, meaning that it's 30 degrees. The angle opposite to root 3 is pi over 3 radian, meaning that it's 60 degrees. And then the 90 degrees is just pi over 2. So this is your type 1 special triangle. Type 2 is isosceles triangle. You know what isosceles means, right? You have two equal sides, 1, 1. 1, 1, square root of 2 triangle. 1, 1, square root of 2. And just like Ishika mentioned, the angle for 1 here is 45 degrees, which means pi over 4. And angle here is pi over 4. And then here's 90 degrees is pi over 2. So that's your type 2. And here's your type 1 special triangles. Now, if you want to evaluate sine of pi over 3 angle, like the ratio, I mean, would you like to use type 1 special triangle or type 2 special triangle to find the answer? Okay, thank you, James. We have to use type 1 because, take a look. Pi over 3 in terms of x-axis, y-axis, pi over 3 terminal arm lives here. Here, this is pi over 3. Pi over 3. If this angle is pi over 3, opposite is square root of 3, and adjacent is 1. Hypotenuse is 2. Do you understand? Therefore, from SOHCAHTOA, sine of pi over 3 is opposite over hypotenuse, which means square root of 3 divided by 2. Okay, thank you, everyone. This is the answer for part or question 1 for pre-calculus. And I think many of you know what to do with the question number 2. What is tangent of pi over 4? How about you guys? I'm gonna give you a couple minutes, say 2 minutes, and give me answer. Whoever comes first, I'll start again. Okay, so tangent pi over 4. What is the answer? Already? Okay. Okay, couple people have the same comment. What does that mean? Most likely, they are correct, and they are correct. So James and Ishika, you guys are correct because tangent of pi over 4, look at the special triangle. According to SOHCAHTOA, tangent of pi over 4 is opposite over adjacent. That means 1 over 1. Opposite is 1, adjacent is 1. Therefore, everyone, here's 1. I don't know how many times I said 1 in just single sentence. Okay, that's the answer for question 2. Question 3, let's do it together. The next question is solve tangent of theta equal to 1. Now, this time, we're not going to evaluate. We're actually going to solve the equation. Do you know what this means? We are actually trying to find out angle. We are trying to find out angles. To make our life easier, can we solve this angle within the interval? The angle theta is in between 2 pi. 2 pi and 0. So we're trying to find out the angle theta between 0 and 2 pi, okay? So let it begin. tangent is theta equal to 1, did you notice that the ratio is positive? Sorry, what is James saying? Can't we reverse engineer number 2 or exercise number 2? Okay, good. Yeah, I see. I see what James is saying. Okay. Mm, so everyone, so Ishika and James and everyone, do you guys think that can we just reverse the exercise 2 so that theta is actually equal to pi over 4? Actually, pi over 4 is right answer. Oh, okay. You didn't mean that. Okay. So Ishika is actually saying that, right. So can't you just, okay, what Ishika is saying is that can't you just, because we know tangent of pi over 4 equal to, 1, can we just do inverse tangent of 1 and get transpose kind of, well, inverse actually, inverse is a better word. Inverse tangent of 1, it's equal to pi over 4. Um, this way actually works if we are lucky. The reason why I'm saying lucky, it's because there might be some more answers in between 0 and 2 pi. Pi over 4 could be just one of the answers. You understand? One of the answers. One of the answers. But it doesn't mean that that's the full solutions. That's the reason why I want you to look at the last number 1 and draw this, everyone. Draw CAST rule. CAST. Have you ever seen this kind of a CAST rule before, everyone? From pre-calculus? Okay. Maya does. Okay, couple people, yes. Okay, good. Okay, Maya, take a look. It's really easy. CAST stands for the following. S stands for the sine. T stands for tangent. C stands for cosine. And A stands for all ratios. For example, sine, cosine, tangent, all ratios are positive. Only sine is positive here. Only tangent is positive here. Only cosine is positive here. So Maya, take a look. When we say tangent of theta equal to positive 1, if tangent is positive 1, in which quadrant does the terminal arm lie? 1, 2, 3, 4. Out of 1, 2, 3, 4, in which quadrant is the tangent positive? Good. Quadrant number 1 and quadrant number 3. So take a look. My dog is barking. Sorry. Okay, sorry. Um. So okay, just one moment, please. Sorry, everyone. Okay, I kicked my dog out. Um. No, I didn't really kick. But yeah, he's interrupting our lecture today. So Martise, do you know Martise? Small dog, yeah. Yes. Um yes, when he doesn't, he's cute when he doesn't bark, yeah. Just now he wanted to get out of my room, but the door was shut, so he just kept barking. That's why I let him out. All right, everyone. Sorry for interruption. Okay, he's not gonna come back today. Okay, so tangent of theta equal to 1 is positive, and just like people mentioned, quadrant number 1 and quadrant number 3. Here and here, you make the special triangle, okay? Special triangle. And you guys know opposite over adjacent is the tangent. So 1 is same as 1 over 1, right? So opposite is 1 and adjacent is 1. Okay. And then of course, by the special triangle, you guys know that the hypotenuse must be square root of 2. If we have 1 root of 2 triangle, what is our first solution, everyone, in quadrant number 1? What is the angle here in red? Okay. It's pi over 4 from the special triangle. Pi over 4 from the special triangle, and then pi over 4 here as well. But okay, so here's the solution. Theta 1, first solution is pi over 4. And then the second solution, you have to go all the way around, half circle, and you reach the last terminal arm. What is the angle for this all the way through quadrant number 3? Okay, good job, James. Half circle, which is pi plus pi over 4 is 5 pi over 4. So 5 pi over 4. And congratulations, everyone. This is the answer for tangent of theta equal to 1. So these two angles solve the equation. Now let me go back to Ishika and someone else. I forgot comment. Inverse tangent of 1 is actually okay, but inversing things, we need to be a little bit careful because sometimes we might lose some answers like 5 pi over 4 and so on. So I suggest you to use CAST rules with the which quadrant is positive and so on, and find out its angles using special triangles if possible. Okay. Sometimes there are situations where you cannot use special triangles. In that case, I'll let you know how to do it. You gotta have to use calculator for that case, but I'll let you know how to do it if you forget. Thank you so much, everyone. This is the end of some of the trigonometric functions review. I hope that it helped a little bit. From time to time, I'll do more reviews on trigonometric functions, especially when we do the integrals. Okay, integrals. Okay. Okay, time to what's our next thing in the plan agenda? You're welcome, Tessa. The next thing in our agenda is a self-study period. You may work on lecture videos for the current video, in-class exercises, or ask questions if you have any questions. Okay. You may leave Zoom or join Zoom, back and forth. It's up to you. Whenever you have questions. But at 4:10, I'm going to have to go over the following. I'm gonna have to go over these questions. It's about fundamental theorem of calculus from module 2-1. So if you want to join me again at 4:10, please do so. You may stay here and listen to someone else's questions if you like. Okay, let it begin. Okay, first question I've got was Tong. Okay, first of all, let me pause the video or stop the recording because it's kind of office hours now.